All right, let me share my screen. There and there. Okay. And share. All right, so here we go. We're gonna talk about immune function and nutrition with our athletes. This is an interesting one. Years ago, I was teaching this course, and we did a little investigation with our football players. Um, did some interviews with some of them, looked at their weights before and at the time that we did the interview, end of October, and found that from August to October, the football players were losing like 15 pounds. Interestingly, as they were getting sicker too. So not only were they losing weight, but they were getting sick. So it was we looked, had the class do some investigating on that, and we talked a lot of the slides that came from that. This was back 9 years ago when I first started teaching. So a lot of the slides that came from that came from some of their research, which was interesting, which was kind of fun to do. So anyway, this is really a homegrown um, um, slide bank based on some research that we did here, and then of course some investigating and looking at the research when it comes to immune function and athletic performance. So pretty fascinating stuff. Yeah, we had the athletes eat more, and they got less sick. That's right, because calories and nutrition, right? You're getting more vitamins and minerals. They're improving caloric intake, and so it worked out better. All right, okay. Start with that story. Here we go. So we're going to look at two parts of the immune system, and they complement one another. One is the innate system, and it's non-specific. So this is stuff that will fight anything that you breathe in or put in your body. So this has a lot to do with the barrier that you are, your skin, and it also does to do with your mucous membrane, and then within the blood itself, the leukocytes, and the phagocytes, natural killer cells, things like that. It also influences cytokines and other immune functions. As we look into this, you'll see that there's a video that you're going to have to watch that I won't be able to play for you here that really explains this well. And I highly encourage you to look over that. So the other system is the acquired system, and this is specific against things that enter our body. So this is why we get flu shots. That helps to boost our acquired system. This is why when we get sick and we build antibodies towards bacterial infections like strep or staph, um, uh, that's why we build a tolerance. This is the same thing with chickenpox. If you had it once, you typically don't get it again because of the acquired system. Obviously, for some of the immunizations we need to get boosters for this, because it just over time our body is going to expend the energy it needs to fight certain pathogens, and if you don't give your body those pathogens, it just doesn't think you need it anymore. So we get boosters in order to maintain that acquired system to fight off those pathogens, whether they're viral or bacterial. So interesting. This is an interesting field of study, and we're going to kind of just look at the nutrition side of it, but we'll have to do a little background. Okay, so this is the video that I want you to look at. Now, if you can't play it on your computer, you can get it off of YouTube. Just look for immune systems and obviously look for the image. Really fascinating. They simplify it, and it's explained really well. So for those of you who are more visual video kind of learners, this might be very helpful. Okay, so our first body's defense, like I mentioned, is our skin and our mucous membranes. This can be impaired by temperature, dryness of the skin, dryness of your nasal passages, so all kinds of things, right? Trauma, things like that. So if you get cut on your skin, you can allow more bacteria in. So there's lots of things that can disrupt this, but most of the time our body does a good job of keeping it fairly healthy and protecting us from things that we're breathing in. And if you've ever stood in a room that has light coming through a window and you can see through that light beam, and you see all that dust, all that stuff floating in the air, well, you breathe that stuff in. So it's everywhere. You may not be able to see it, but you're breathing stuff in. So just an example of what the skin does. Someone touching the outside of the skin, and I realize that it's a really poor image, but the idea is that we have natural killer cells and phagocytes and leukocytes that are within that system that protect us from anything entering through the skin. Here's kind of a breakdown of what that looks like when we talk about leukocytes. Leukocytes is a big general term for lymphocytes and T cells and monocytes and all these other things. And you might need to recognize for an exam in this class, certainly should be aware of it, just because you need them, and it's kind of nice knowledge to have. If you take pharmacology classes or bio classes, you'll go into more depth with these. Most of the time we call these leukocytes white blood cells. They're different types. They have different jobs. If you watch the video, you'll kind of get a breakdown of some of the types and some of the jobs. So just the idea that we can influence these. These are proteins. So we can influence these by how many amino acids we eat, the type of vitamin and minerals that we consume, all help in the creation and the sustaining of these leukocytes, these white blood cells in our body. So it's really important to maintain good nutrition and, of course, good carbohydrates, the calories that we need in order to fire up these systems, either to create these things or to get them to work within our body. So good nutrition obviously is super important to maintain our immune system. Another video of this, it talks just about exactly what I said. Once again, we put this in here if you're more of a video or audio learner, so it's there for you. Talks about the same thing. So what do we do to decrease immune function? We can decrease immune function with exercise. So not all exercise is good. Certainly the number of immune fighters and their function can be decreased by intense bouts, and I mean intense. So if you look at the word intense or prolonged, that doesn't mean you shouldn't do those things. It just the important thing to remember here is if you're doing something intense above 70% of your max heart rate or prolonged greater than about 20 to 30 minutes, you're going to increase your chances of getting sick just for a little while. We call it an open window of effect. And so we'll talk more about that here in a second. I'm in no way saying that you shouldn't do intense bouts of exercise or prolonged periods of exercise. I'm just saying that even with good nutrition, you're going to open a window of accessibility for bacteria or even a virus to get into your body. Some of that has to do with stress hormones that we create when we exercise, cortisol and epinephrine. Some of it has to do with the fact that when we get those things, because we're having a higher respiration rate, we're breathing in more of these bacteria, these more viruses, our body's working harder to get rid of it. We create more leukocytes to fight it. Those leukocytes are immature. So the maturity level of the leukocytes, how tough it is and how good it is at fighting stuff off and messaging other leukocytes to fight it off has a lot to do with it as well. So less mature leukocytes has a lot to do with it. We lose glutamine. That helps break down proteins. If a virus is in your body, it's a protein. If we have less glutamine, we don't break it down as well. That's falls in high bouts of intense exercise. So glutamine is a reason as well. We create a lot of what we call ROS or reactive oxygen species when we exercise, especially when we do eccentric work like running or jumping, things like that. Creates a lot of reactive oxygen species, which increases the work that our immune function has to do to fight that stuff off. Look, once again, it's okay to do intense exercise. It's okay to do prolonged exercise. Just realize that these things right here are reasons why we may end up getting a little sicker after those bouts. We just have to be careful. Just don't be around sick people after you do these exercises. Keep yourself, in a safe place, I guess, and I'll show you the window. It's not a very long window. And I'll talk about when this kind of stuff is really prevalent. So here we go. A lot of the upper respiratory pathogens that we have, the thing that affect our respiratory tract and gives us head colds, basically, are airborne. So airflow patterns, of course, when we're exercising increase, so we breathe in heavier. And so we do less nose to mouth breathing, which sends it through our sinus cavities and can prevent more. So we do more mouth breathing that's directly into our lungs, which can, increase the chance. More cooling of the air, more cooling and drying out of the mucous membranes within the respiratory tract can increase our chance. Dehydration can increase gut permeability. So all of these reasons contribute to an increased chance of being sick. However, there is some good news. So when we look at some of the immune system, the army, I like to put, we have natural killer cells, macrophages, neutrophils, and cytokines. Our bodies do a great job of increasing these with moderate exercise to help protect us, which is an awesome thing. So when we look at studies that look at cytolytic or natural killer cell reproduction, if you will, we get 150 to a 300% increase in natural killer cells, which fight off viral infection. And it lasts a little less than an hour, but immediately after exercise. So our exercise increases the production of natural killer cells, which is great because as we're breathing in more of these viruses and all these other things are happening that decrease our chances of fighting off infection, our body knows this. It increases the production of natural killer cells by 150 to 300% and allows us to fight off some of those things. Within 30 minutes of the end of that exercise, we start to see a drop in those natural killer cells. So that's when we have to start to be careful again. It opens that window up. So we'll get an increase right away while we're exercising. It decreases about 30 to 45 minutes afterwards. Now, natural killer cells are really interesting. They introduce themselves to a target pathogen. They basically reach out with a receptor and they shake hands with that target. And if the target doesn't match, then it pulls it in and it eats it. So it's kind of a cool process. And, that's just one of the things that help us. Macrophages are another one. They do phagocytosis and they gobble up foreign particles as well. With acute strenuous exercise, we get an increase in the macrophage count and a lot of their function. So they become more powerful and they become more numbers. Now, with long-term exercises, we may get a little decrease, but the function is still greater in untrained athletes or untrained people. So even with long-term training, we may have a little deficit in them, but it's still better than people who are sedentary. So it's good to exercise, I guess is the point. It'll increase macrophages. Neutrophils, same thing, does phagocytosis. Here's kind of a picture of it. There's a little piece of bacteria. It gets swallowed up. It forms a phagosome, goes in and introduces some killers in there called lysosomes, and then it pushes it out the other end of that little cell. And the little push out after it's all been broken up, it gets the cytokines really excited, which we'll talk about in a second. So there's a little process here that helps build our immunity just by doing it. Now, with acute exercise, so when you first start your exercise, we get a neutrophil count increase, and then it lasts for several hours. For long-term, moderate training increases it, but intense training decreases them. So moderate training, anything below about 70% or so or below. Intense is above that. So if you keep your heart rate in a good, aerobic state, basically, then you're going to do fine. Once again, if you go into intense bouts of exercise, you're doing lots of sprint work or running stairs or heavy lifting, that's fine, right? You're going to get an acute increase, but then over long term, you really do have to be careful after the exercise that you don't expose yourself to pathogens that may make you sick. So stay away from people who are sick is basically how that works. So once again, neutrophil activity, moderate exercise increases it, intense exercise suppresses it. So when we look at endurance training, we get a reduction in some neutrophil function, but it's still better than being sedentary. Okay, so anyway, it's important to it's important to exercise, I guess is what it comes down to. And we're going to look at that in a second when we talk about something called a neck check. So cytokines are, I like Paul Revere here. Cytokines are messenger proteins, and basically they get influenced by the immune response, and they get a bacteria or virus will be recognized by a cytokine. They'll realize, we need to either increase inflammation into an area to make it more volume so we can do more, battle, or we need to decrease it. So our cytokines are pretty smart. They also are messengers, so they send it out to like other immune function cells that come in and can help fight off infections too. So cytokines are pretty cool things. These are the ones that we have to be careful of. This is why when you cut your hand or you have a little paper cut on your finger, you get a little swelling around it, that's cytokines, right? And it's also gets a little red, it's also cytokines. It's telling your body, hey, we got an open wound here. We got to bring in the right stuff to close that up and protect this from the, invasion through our skin. So cytokine works in the body and on the skin, and they're just amazing little molecules. So, or little proteins. Okay, so once again, another video that talks about just what I did. So if you're more of a want to see a video, also available on YouTube, you'll see the link in Canvas. So okay, so here's the acquired ones. So those other ones we just talked about were innate. They are fight off anything. These are acquired. And so the acquired ones need to get taught, basically. They go to school. So when we're exposed to a pathogen, whether it's a virus or a bacteria, our bodies will look at it, eat it, figure out what it is. And if we recognize that we can form these T and B lymphocytes, these are just two examples of a very big, complex way that we fight off stuff. And basically, they then secrete something called antibodies, and now we can fight off in an antibody state. We can fight off bacteria. An antiviral state, we can fight off a virus. And so, once again, we can mass produce these and call them, like your flu shot. So. I just lost the word for a second, excuse me. Anyway, we can mass produce these and we can give you, a flu shot, or we can give you an antibiotic through a pill form, or sometimes even injectable. So we can fight them off even better, because our bodies can only produce it so quickly, and we can then use the immunization, to help boost that function in our bodies. All right, so lymphocyte counts and B cell functions are decreased after intense exercise, but not after moderate. So once again, moderate exercise really seems to be the key to boost our immune function. We can impair antibody production with prolonged intense exercise as well. And remember, there's this immunological open window that occurs with not only our acquired, but our innate systems when it comes to immune function. So just know that there is a time period where after about an hour, or 30 minutes to an hour after exercise, we can be compromised. And so it goes on too. So it starts 30 minutes to an hour, and then it goes on. It can go on for a day or two, just depending on what you're being exposed to and your immune function prior to the exercise. So just be aware that if you're gonna do something intense, like you're going to run the turkey trot, right, or some race at Thanksgiving, and then you're around family who may or may not be sick, that could be a time where you could get sick. So here's just an image of that. So here's the open window down here below. So you get a stimulation of the immune function. It jumps up with heavy exertion, and then it drops way below your moderate activity line. And so you're more likely to get sick because you're immunodepressed down here. So as you can see, it can last up to 10 hours and days, depending once again on what you're exposed to. So just be aware, right? Just be aware that there's a chance, and it's not a huge chance, but there's a chance that you can get sick after exercise. Obviously, athletes are prone to this because of the practice schedules that they have, and so we have to look at them in kind of a special case. Something called an upper respiratory tract infection, that's URTI. This goes right along with what we talked about with the moderate and intense exercises, that after intense periods, they can be more susceptible to minor infections. They can have an increased upper respiratory tract risk. So we just have to be aware. We've got to keep our athletes well fed and have a good vitamin mineral regulation, so that they're constantly having vitamin and minerals passing through them, either through the foods they eat or through a supplement. Which brings us to this thing called a J curve. J curve is certainly going to be on your test. I really hope that you use this page of page 20, slide 20 of this when you take the test, that you don't go Googling this. It gets confusing with Google. Here it is in the nutshell. Your risk of an upper respiratory tract infection, your average risk starts right here. If you are a moderate exerciser, you decrease your chance of getting an upper respiratory and tract infection. Once you hit higher intensities of exercise, your risk goes up. This is called a J curve. Our athletes do great, and most everybody does great with moderate exercise. Most of our athletes have to do some bouts of intense exercise. Therefore, they're at a greater risk of an upper respiratory tract infection after their bout of exercise. So we have to be careful with them. Here's the little explanation. So the basketball team goes to a game. We have one player that is sick or feels sick. They all play the game. They all increase their ability to fight off infection for about 30 minutes. So they go into the locker room, maybe they take a shower, maybe they change their clothes, and within 30 minutes, now they're sitting on a bus and they're driving home. So they're stuck on a bus for an hour to 3 hours, depending on how far they have to travel in rural Arizona for their game. And now they're being exposed in that window of time, right, to the athlete who may or may not be sick. So that's where a lot of the problems come from, right? So what do? Well, maybe we mask. I don't know. Maybe you just don't sit next to the guy who's sick or thinks he's sick. It just increases your chance. Are you going to get sick every time? Probably not. But the idea is that there's a risk that remains there. So if as a coach or another player or as an athletic trainer or somebody, that has to be aware of those things, should be aware that by the time you get to your bus after a game, you have because of the J curve theory, you have an increased chance of infection or sickness. Okay, some factors that may impair it. Obviously, poor nutrition. The older we get, we have a little tougher time with our immune system. Certainly cigarette smoking, stress, and lack of sleep. So any of these in combination, right, make it worse. So if you have poor nutrition and you're stressed and you're not sleeping, you're increasing your chance. If you're stressed and you smoke and you're old and you don't eat well and you don't sleep well okay, so you get the idea. You can make it worse by compounding these things. Obviously, athletes should avoid being around people. They should get a flu vaccine. That's highly recommended by the NCAA, NJHCAA, the Athletic Training Associations, everybody, AMA, everybody suggests that we should get these things, a flu vaccination. And we should. So here's a video about flu vaccinations and how they came to be. Just a quick video on that. There's plenty of this be careful with what you watch, make sure it's reputable. Okay, so this question is what posed to me a lot. So should an athlete train during an illness? Well, it depends on the illness. So if the symptoms are restricted to just one system like respiratory or the upper respiratory tract, yes. If they're generalized systems, they have fevers, things like that, the answer is no. So if they're just got a cold and they're not running a fever, yeah, then they should practice. Typically, the practice should be done below 80% of their max heart rate. So in the moderate category, that's tough to do if you have a coach that's not cooperative. Our coaches here at Eastern tend to be pretty cooperative when we talk to them about this kind of stuff. They should focus more on their skills, like shooting baskets or, things like that, as opposed to running plays up and down the court, that kind of stuff. So they maybe tennis serves instead of playing a match, things like that. So if they have general malaise, they're fatigued, they have muscle pain, aches, their temperature is above 100, the resting heart rate is greater than 10 beats per their normal, then don't let them practice. Tell them to just go rest. However, if that's the case, then we're going to wait, right? And the docs recommend 2 to 4 weeks. But however, we can keep an eye on these and we start to feel better and we start to lose this and we're now just one system, like maybe just upper respiratory, then we can get them back doing skill work and doing moderate exercise. So it's not all or none for 2 to 4 weeks. We can gradually bring these guys back. So that's kind of the idea. We want to be careful of dehydration and exhaustion and things like that. But they can practice as long as they don't have a fever or body ache, excuse me. All right, so we call something called a neck check. So if their symptoms are above the head, they maybe have a sore throat, or maybe they're congested, or maybe they have a little bit of a cough, go ahead and practice. If they're feverish, they can't practice. If the neck check is there, so symptoms are just above their neck, sore throat maybe, cough, congestion, then they can start practice. We check on them about every 10 minutes. We make sure they're not doing too intense. If they're feeling pretty good after 10 minutes, they can continue to practice. We check on them again after about 20, and then it just keeps moving out from there. Our coaches here are pretty good about this, and our athletes do really well. So if they come in with their just symptoms above the neck and we get them to practice, they tend to recover a lot quicker than if we just sent them home. A lot of that is because then they're just re-exposing themselves, because a lot of times they're ill, they sleep on their beds, they get up the next morning, they come to practice, we tell them to go back, they sleep on their beds again that have been, they've already coughed on their pillows, and they don't change their sheets or whatever. They're just re-exposing themselves, and sometimes it makes it worse. So it is good if the symptoms are above the neck to let them practice. Make sure you're checking on them every 10 minutes. Their intensity isn't very high, and that they can tolerate the exercise. And in most cases they can, they recover fairly quickly. So here's the neck check again. Once again, headaches, runny nose, nasal congestion, fatigue, sore throat, maybe a small cough just because they're getting some postnasal drip. Definitely not a low-grade fever, no body ache. So here's your neck check. Keep an eye on that when you do your test. So some nutritional concerns. We're looking at people who are voluntarily restricting diets tend to be a concern, and athletes who large amounts of it consume a large amount. So if they're bulking, so we've got to have a real moderate intake of food. So either not enough or too much can impair, just because it's based on energy, right? It can impair immune functions. Once again, when we look at macronutrients like carbs, fats, and proteins, we know that proteins play a role in immune functions. We like to keep protein intake up for our sick people. Certainly the same thing with carbohydrates. They need to be kept up so that we can power the protein synthesis that makes new cells, and so we can keep the functions going. We look at vitamin and mineral intake. Certainly we need to keep vitamin and minerals moving through our system so that we can create those proteins when we combine amino acids with those vitamins and minerals to make those proteins. You've heard of some of these, like vitamin C, beta carotene, zinc, all have specific functions with the immune system. So those are usually the ones we hear about taking. We take these because of these things called free radicals. I mentioned ROS before. So if you watch this video, it talks about antioxidants and free radicals and what we need to do to eat them. And here, basically, it comes down to this. We either keep vitamins and minerals in us, or we eat lots of bright, colorful fruits and vegetables, and that'll help keep those good antioxidants in us as well. I highly recommend our athletes taking some sort of vitamin supplement, just because of the nature of their schedules. They don't always get to eat as nicely or clean as they can, and so it's nice to have vitamins on it. Probiotics are really important too. You get those in your yogurts just for good gut bacteria, especially for our athletes who chronically get dehydrated during practice. Here are some basic 30 to 60 grams per hour of carbohydrates. It doesn't change much for those who are ill or non-ill. So this is just to maintain good immune function. Here are some of the primary goals that we're looking for nutritional uptake. So fluids, vitamin C. However, I think you can get this. We need so little of it. We could probably get this in our diet. Echinacea, an herbal preparation, tends to help as well. So anyway, you can take some supplements. Once again, good diets are great. If you can't get a good diet and you can't maintain a consistent diet, then you probably should do some supplementing with vitamins and minerals. Okay, here's your terms. Pretty straightforward. Know your recommendations for carbs, proteins, and fats. By the way, fats there doesn't do anything for our immune system. So fats, eat them because it makes you feel full and it might make the food taste better, but it's not going to really help your immune function. Okay, so that was a quick run through that slide bank. Once again, watch those videos. They'll be helpful. And if you have any questions, go ahead and give me send me an email or a text. All right, you guys.